Hello guys, we will learn or we will go over the composition of trig values today. Let's start by looking at our problem number one, which says secant of sine inverse of 5 over 7. First thing you have to do, of course, is figure out what is inside the parenthesis. Our order of operation forces us to start inside the parenthesis. The sine inverse of 5 over 7. Sine is the big belly, so I'll draw it in the first or fourth quadrant. Being positive is in the first quadrant, where the opposite is 5 and the hypotenuse is 7. So this is 7 and this is 5. So if you use your Pythagorean theorem here, you will end up with 2 square root of 6. Now, to find the secant, you don't necessarily need to figure out what the angle is because we have all information on the triangle. So the secant is the hypotenuse over the adjacent. Hypotenuse here is 2 square, actually it's 7, and the adjacent is 2 square root of 6. So if you make it fancy, you will say this is 7 square root of 6 over 12. And that will be your final answer. Let's go ahead and do the same for problem number 2. For problem number 2, I will start inside a parenthesis with the secant inverse of negative 3 over 2. The secant of negative 3 over 2 belongs to the cot. Negative means I'm going in the second quadrant, where my hypotenuse is 3, my adjacent is negative 2. Using once again your Pythagorean theorem, you will end up with square root of 5 here, because 9 minus 4 is 5. At this point, I can find the cotangent, knowing that the cotangent is adjacent over opposite. Cotangent being adjacent over opposite, my adjacent here is negative 2, and my opposite is square root of 5. Of course, I like the answer to be fancy. I would say negative 2 square root of 5 over 5. All right, let's go ahead and look at problem number 3. It says cosecant of tangent inverse of negative 5. Remember, this is over 1. So apparently, the opposite is negative 5, and the adjacent is 1. Tangent is the barely 1, and being negative is in the fourth quadrant. So opposite is negative 5, and adjacent is 1. Using once again my Pythagorean theorem, I will figure out that this side is 26 because that's 25 plus 1 all under a radical. To find the cosecant is hypotenuse over opposite, hypotenuse being square root of 26, opposite being negative 5. I just put the 5 in the negative, and that should be your answer. Number 4 says secant inverse of sine of negative pi over 6. Negative pi over 6 is located in the fourth quadrant. So I will graph my negative pi over 6 in the fourth quadrant. Sorry about the belt. Since this is negative pi over 6, reference angle is 30. Across from 30, I will have that negative 1. This one will remain square root of 3, and this is 2. Now, to find the secant inverse, let's finish with the inside of the parenthesis. The sine of negative pi over 6 is negative 1 over 2. So now we're looking for the secant inverse of negative 1 over 2. It's like a whole different problem. Secant is a cot, being negative is in quadrant 2. You don't necessarily need to draw this triangle because all you have to do is hypotenuse over opposite. Hypotenuse apparently is 1 when the opposite is 2. That is not possible. The hypotenuse is always the longest side of the triangle. Let's look at problem number 5. We have the sine inverse of sine. I know you might think that this one are opposite operation, therefore the answer is 4 pi over 3. Don't go too fast. I will tell you why it's not just 4 pi over 3, although sine and sine inverse are opposite or inverse operation. Let's start with the inside. Inside the parenthesis, I have 4 pi over 3. That's located in your third quadrant. Reference angle is 60. So across from 60, I will have square root of 3 or negative square root of 3 in this case. This one will be negative 1 and this will be 2. So the sine of 4 pi over 3 will be opposite, meaning negative square root of 3 over 2. Now, sine, cut off big belly. Of course, that's the big belly. Fourth quadrant because it's negative, and that's my opposite. And this is my hypotenuse. The only angle that has an opposite of square root of 3 is a 60 degree. But since I'm located in my fourth quadrant, I will say negative pi over 3. Secant of cosecant inverse of negative square root of 5 over 2. Let's start by finding the cosecant inverse of negative square root of 5 over 2. This is the value once again. Being negative is in a fourth quadrant. And I have the hypotenuse is square root of 5. This is h. And the opposite is 2. Of course, it will be negative because it's going down, and there's a negative there. If you use your Pythagorean theorem, that will be 5 minus 4. This will end up being 1. So if I try to find the secant of this specific angle, I would say secant is equal to hypotenuse over adjacent. The hypotenuse here is square root of 5. The adjacent is 1. So my final answer is just square root of 5. Remember, I told you that sine and inverse sine are inverse operation. Yes, they are. Unfortunately, they will not give you the same value unless you're into the restricted range. In other words, sine inverse of sine of x is equal to x only if x is in the range of the inverse sine, meaning the belly, negative pi over 2 to pi over 2. I can say the same thing about the inverse sines of, let's say, cosine. Cosine inverse of cosine of x will only be equal to x if and only if x is in the interval from 0 to pi. I'm going to put brackets here. Why not? From 0 to pi. That's for the cosine. Of course, this will also be true for cosecant and tangent. And this is also true for secant and cotangent.